Rate limiter. Rate limiter. Where do you use rate limiter? So if you have APIs, and those are hosted by what, the API servers, and API servers are behind what, API gateway, and API gateway can implement, for example, this rate limiter. One of the places where rate limiter can be used. So what does rate limiter do? Rate limiter basically literally means to limit the number of, let's say in API case, limit the number of API calls. So in this case, that if you want to build scalable APIs, then um, uh, you need to secure your API from bad users from abusing the API, and rate limiter keeps a counter on the number of requests received. So let's say you have a threshold that my API should not be called more than 10 times per minute, let's say. So you can implement a rate limiter that request 11th and so on requests are denied, something like that. So that's what rate limiter is by definition. Now let's see. This diagram pretty much sums it up, that if you have so if you have a user, and user sends a request, and that goes through the rate limiter to the API server. So if rate limiter passes it, it goes to the API server. If not, it is stopped. So check rate limiter rule: reject a request if the threshold exceeds, otherwise let the request pass through. So implementation wise, it's saying that Stripe uses token bucket algorithm to do rate limiting. There are other algorithms as well. For example, see here, there are sliding windows, leaky buckets, token bucket algorithms. But for now, just know that there are different algorithms for rate limiting. In this case, it's saying that Stripe uses token bucket algorithm. So you have limited number of tokens that you can use. In this diagram, you can see, so that's the user trying to request, and it will, for each request, it checks the bucket, let's say, and if tokens are left, then tokens are left, then you proceed. If no token is left, then request is rejected. Similarly, there are and tokens get filled at steady pace. Similarly, there are other algorithms like sliding window, fixed window, leaky buckets. And how do we implement rate limiter? We can use a data structure, like very simplistically, let's say there is a hash map, and you want to implement it user wise. Okay, so against the user, you keep the count of the number of requests they have had, and that's a very simplistically that is a way to do it. But anyway, even if you make it more complicated, how will you do it? You can use one of the ways would be to have Redis like in-memory data structure, which provides low latency. Now, what are the considerations while implementing rate limiter? Clear responses. So if it is the reason that you want to reject a request, so you can, let's say, one of the reasons would be 429 too many requests, or that 503 service unavailable, it got cut here. And similarly, there are panic modes, such as in that case you switch off the rate limiter on failure. And there are other alerts and monitoring, and there are also tunings based on traffic patterns, that the rate limiter can tune itself, change the behavior a bit based on traffic patterns. So that's this page. Now a potential solution how rate limiter can be implemented. So basically, there can be two simple ways to implement rate limiters. How will you identify the uniqueness of a request? So it could either be by IP or probably by user. So let's say we are doing by IP. So a potential solution, it's saying that you can redirect the traffic from an IP address to the same data center using DNS, and have an isolated rate limiter in each data center. So let's say from one particular IP address, all the requests are going to one data center, and in that data center, once it reaches that, you have a caching proxy which caches the requests, and hence all the requests that's going from one single IP is goes through that proxy and it's cached there. Hence you can build any logic over that. So any logic that decides whether to allow the request or not can be done there. And again, the last point is to use consistent hashing to reduce key distribution on changing load. So changing load means again it can go to different servers, right? So even if all the requests are going to the same data center, it can go to different servers. So if something goes wrong, one of the servers fail, in that case the key distribution happens, right? So consistent hashing to reduce key redistribution on changing load. That's about a potential solution. Now rate limiting types. So this one is covering 4 types of rate limiters. Request rate limiter is one, where very simplistically n requests per second. So every second you are allowed n requests. And if we talk about concurrent request rate limiter, here it's talking about concurrent requests being handled by the server, and in that case it's saying that you'll have some percentage available for high CPU intensive usage, and some percentage for low CPU intensive usage. So let's say before rate limiting, this high CPU usage was covering this much, but later on, let's say you say resource intensive, only 20% of the request will be resource intensive and rest will be given for low CPU usage request. So that's concurrent request rate limiter. And for fleet usage load shader, in that case, see here, before a rate limiter, the non-critical traffic was covering, let's say 80%, only 20% is, or non-essential are covering 90%, and only 10% given to essential traffic. But after rate limiter, you can define that 20% has to be given to the critical traffic, and the rest can go to the non-critical traffic. And the last one was worker utilization load shader. In that case, this is the last line of defense, as it says, and it is and in this case, all the non-critical traffic gets shed, and the system is only serving highly critical traffic. So that's about it. Thank you.